Okay, good morning, everyone. In today's session, we are going to discuss about the Unit 5th. So earlier we have covered some topic from the Unit 5th, but in today's session, we'll revise those topics again as per the request from the student. And the Unit 5th is consist of basically two topics. One is a Hadoop MapReduce framework, and another one is a R language. So we'll first cover the Hadoop MapReduce framework. So why the MapReduce framework is important? Because it will give us a capability to deal with a large amount of information. So how is it favorable to work on the large amount of information? Because when we are dealing with a large amount of information, the many constraints come into the picture. One constraint is processing. So do not have a high processing capability. And if we are able to arrange that, then it is very costly. So it is not a cost-effective application to invest a lot of amount in processing capability. Another thing is the storage capability. To store a large amount of information on a single premises is not feasible sometimes because uh, you can't make a simple storage to store information which is in a terabyte. So you have to be rely on the multiple storage entities. And what you can do, you can combine those entities and make a system such that which can operate among these storage entity, and they will be used as per their requirement. So these are the two things which will require investment, as well as they will require the human resources. So that is not feasible for most of the application which is running on the big data. So for example, if you are running an application for startup enterprises, then you will find out that do not have too much money to invest in the starting phase of the businesses. If they want to process the big data, they need to rely on the services which is cheap, which should be cheap, and must provide a large scale solution. So Hadoop MapReduce come into the picture for this kind of situation. So basically, first it will deal with the processing power by using multiple systems. So these system can be dedicated system, or these systems can be voluntary contributed by the community. So in first phase, when we are dealing with the dedicated system, again it will require a lot of investment. But when we are having support from a community devices and they are voluntarily contributed, then again you are getting a resources at a less cost, and they are offered by the some other third party users. So you can take the help of those resources. So it will solve two problems. One problem is processing. So how the processing will be solved by using community system? As we know that a single system has a limited processing capability, and when we combine multiple system at once, then we have multiply the processing capability of our application. So what will happen then? If you have 100 system as a community cooperation, then you will find out that these 100 system will multiply the capability of single system to the 100 times. So that will be enough processing capability. And a second problem that can be solved by this phenomena is that whenever you are working with storage of the data, which is a big data, then you can store this amount of information in a on a community devices by distributing among them the devices. Now we have slightly solved a problem toward the storage and processing. Then MapReduce is basically will take care of each and everything. Then when you will provide big data, as well as you will provide your programming logic to the MapReduce framework, it will take the data and it will apply the processing logic, and whatever the result it will generate, the result will be displayed to you. Now the MapReduce will take the data, divide the big data into smaller data sizes, and distribute among the different devices. Same thing, it will take the task, and what the tasks will be divided into subtasks, and these subtasks are distributed among the different devices. Now the question arises, how there will be ensure that cooperation among these different systems. So for that part, MapReduce has its own features which will monitor all the devices which are currently working on a given task, and these devices will continuously reply to the MapReduce framework that what is the status of processing and what is the status of the storage. One important thing when we are processing a big data is that we have to be make sure there can be multiple casualty. That casualty can be arises from human error, or it can be arises from natural causes, as well as it is also possible that device failure will cause those problems. In all the situation, suppose a collection of system will facing one of these problem, maybe some manual intervention created some problem within the system, or some natural disaster created a problem. And third one, let us suppose that some hardware failure took place. So what will happen? These collection of system will lose their processing capability, as well as they will lose the data that is being stored on that particular systems. Now the Hadoop MapReduce system have a problem here where it has to find out a solution which will take care of these losing processing capability as well as the loss of data. So MapReduce will provide a feature. By using that feature, will make sure that these different phenomena will not cause any loss of power or will not cause any loss of data. We'll discuss about that, how the MapReduce will framework will take care of all those loss of data and loss of devices, loss of processing power. Let us discuss the first point. Uh, a frame is a framework using which we can write application to process huge amount of data. The primary task of MapReduce is to process a huge amount of data. So basically, why do we want to process a huge amount of data? Because we have a certain requirement from those data, and whatever the outcome of those data, we want to feed to some kind of application. These application can take those information, and based on those information, they will be have as per the plan. For example, suppose you are having a text processing capability, then what will happen? You will take a large amount of information as a text data. Now these information will be feed to the MapReduce framework, and your application logic, as per your desired requirement, will work on these amount of information, processing those kind of text information, analyze the text information, and find out the usual pattern, or find out the desired pattern or hidden pattern inside the text information. So that can be one application. Suppose you want to make a weather forecasting application, Then you have to deal with information generated from weather department, as well as you can take the data from the different geographical regions. You can take some data from international organization and so, and you can collect all those data and process them in a real time. Another application can be your autonomous car driving. As you can know that autonomous car driving will depend on various information. Uh, they will depend on the present scenario, what is the condition of the road, what is the obstacle on the road, what is the traffic light conditions, what is the number of vehicles on the road, as well as they will also depend on the weather data. Suppose is it going to rain, is it going to snowy day, or is it going to be a sunny day. So you can find out that these kind of information is very much required when we are working with a large amount of data. You can think of various applications that will use this huge amount of data to process the information. So MapReduce framework is designed primarily for processing the huge amount of data. It will work in a parallel environment. So parallel environment means, suppose if you want to work on an autonomous car, then what can you do? You can process multiple information, or you can process multiple chunk of information at a parallel or a distributed environment. Whether you can process the traffic condition on a one single cluster of system, or you can process the weather forecasting on another cluster of computers. You can process the traffic path system on any other cluster of systems. Now, you can find out that these distributed environment will give us the capability to the map reduce, uh, give us the capability of map reduce to process the information in a distributed and parallel environment. Hadoop MapReduce program model for distributed computing based on Java. Primarily, we need to have the knowledge of Java programming language, because whatever the application logic will write for Hadoop MapReduce framework, that should be written in a Java programming language. So if we are having a Java programming language knowledge, that is very good for Hadoop MapReduce. And if you are having do not have a basic knowledge of Java, so you should not be go in a deep about the Java. A basic knowledge of Java is sufficient for writing the application on a Hadoop MapReduce. Hadoop MapReduce uses the multiple computing nodes. Uh, these nodes will help it to scale the processing. What is the scale processing means? Suppose if you are having a one single system and you are computing some data, then what will happen after adding more computer to the another system? What will happen? You will scale the processing. So it will again Hadoop MapReduce provide you a scaling feature which will take care of the users. If the users are increasing, then what will happen? It will add on the system and increase its capability. And when the users are decreasing, it can release some resources for any other task. Next. So MapReduce algorithm contains two important tasks. One is a map, another one is a reduce. So what is a map and what is a reduce? So basically map will take a set of data and convert it into another set of data, where individual elements are broken down into key value pairs. So basically when you will provide the data set to the map produce framework, then what will happen? Map will take these data set and will convert those data set into key value pairs, where key will be used to represent the data and value will be the value of the data. So it will help the MapReduce framework to find out any required data set to perform any type of processing on the data set. What the reduce will do? Reduce will take the task and from the output from a map as input and combine those data tuples into smaller set of tuples. So basically, reduce will take the output from each and every system and will analyze those output, and based on the output it will give you a final output, what will be the output of the system. So let us take example of text analysis. Suppose we have a text data. Now you have to create a key value pair for each and every text information so that it can be feed to the mapper. Now, when you will feed the system, you will apply your logic on the map. Then what will happen? It will process the chunk of information by using the application logic on different kinds of cluster of system. Now they will generate some output. So suppose they, if you're having an n cluster, then the output will be generated from O1 to O1, O2 up to the n. So there will be n number of partial output. Now can apply the reduce, and the reduce will take all these output and combine them as a one output, so that whatever the final outcome of text analysis, you will get those output. So you have to write your application logic such as it will take all the information and again combine those inform output of those information and provide you a better way of insight. Okay, so earlier we had discussed one question. What is a file system of any operating system? So any student want to give their view? What is a file system? Anyone? Any idea about the file system? Because when we are working with the Windows, we are depend on the some kind of file system which will take care of each and every information that is stored in our own system, how these information will be processed, and how these information will be handled by different applications. So do you have any idea about the file system? Anyone? Okay, so I will assume that you are well aware about the file system. So different operating system will using the different file system. These file system are designed for operating system so that they can store the information, and whatever the logic or application written for that particular operating system will take care of, will aware about this file system, how they work, how they access the data, how they are going to store the data. A Hadoop MapReduce system does not use any operating system file system, because it will take care of, or it will have a different aspect while it is processing the information. For example, when you are working on your operating system, these operating systems are not designed to store big data or large amount of information. They are designed to work for the data that is required for day-to-day activity. But when we are dealing with Hadoop MapReduce system, as we had earlier discussed, that Hadoop MapReduce system, the primary task to process a big data. So now the primary concern for file system for Hadoop MapReduce is to handle the large amount of information. When we are dealing with a large amount of information, what will happen? We have a storage problem because a single system or single server could not have or could not be used to store a large amount of information at one. we need to be rely on multiple different systems. Another problem is, suppose we have discussed three scenario where your data can be lost. One is a manual intervention, where a system will be manipulated by some humans. Another thing is, second one is a natural disaster, where some kind of natural phenomena happen and it will create a chaos for the whole collection of system. And third one is any fault in within the systems or devices. So when we are dealing with large amount of information, we need to deal with distribute those information. We need to be very fault tolerant. Again, these file systems should be designed such as if we require some kind of information, it should be accessible instantly and in a faster way. So that should not be done with the operating system or Windows or Macintosh or Linux file system. So Hadoop MapReduce has created its own file system and we call it a Hadoop file system or HDFS. So the concept of HDFS is same. It will store the information as a file and directory as we are storing it within our own operating system. But the whole phenomena of accessing storage of the information is completely different. Now we'll discuss about the Apache Hadoop. Apache Hadoop is an open source software framework and it is used to develop data processing application. And these applications are designed to work in a distributed computing environment. So when you want, again, open source software framework means it is completely available, freely available to everyone. So you can download the Apache Hadoop and you can install on your own system and can work on with Apache Hadoop framework. Basically, it will be installed on the Ubuntu Linux system or any given Linux flavor. So there are various steps that can be taken care while you are installing the Apache Hadoop software frame. It is a freely available, so source code is available to you. There are community support is available to you, so we can install the Apache Hadoop on our own system and create an application that will process the large amount of information. And we can also install the Apache Hadoop for a distributed computing environment. Suppose you have a multiple system, so you can install the Apache Hadoop for all the system. So basically, when we are going to install the Apache Hadoop, we will find out two ways. One is a single node system, and one is a multiple node system. So when we install the Apache Hadoop for a single node system, then the master and slave. Master means the controlling authority, which will controlling the whole operation of Apache Hadoop MapReduce framework. And slave are those devices. They will take the data, they will process the logic, and they will return the output to the Apache Hadoop MapReduce framework. So when we are working with application on a single system, the single node will work as a master and slave both. But when we are working a multi-node system, then the master node will be a completely different from slave node. Then one of the system will work as a master node, and all other system will work as a slave node. Now, application built using Hadoop are run on large data set distributed across cluster of commodity computers. As we have earlier discussed that these these applications are designed to work on the large data set. So again, when we are working with a large data set, we require more number of computer system for to increase the computing capacity as well as to increase the storage capacity. how can we avail those features by using the commodity computers or cluster of commodity computers in a distributed environment. So when we are installing the Hadoop MapReduce, you have to make some configuration regarding the number of commodity computers or number of node and inside the master node. So for every devices, they must be aware about which is a master node and which is a slave node. So that particular configuration must be taken care by developer or us. And after that, when we give our data set and application logic to the Hadoop MapReduce, it will take care of all the distributing of information to different commodity computers, as well as distributing the task among the different computing commodity computers. Why we are favoring the commodity computers? Because as you know that investing in a new system is costly affair, and for most of the application developer, that is not a solution, because they are rely on some tight economical support, which will not allow them to buy new devices or new system. So they will use the commodity computers for better alternative. These computers are cheap and widely available to everyone. These are mainly useful for achieving greater computational power at low cost. So again, when we are adding the commodity computers to one by one, what it will do, it will create a more computation power, and it will add on those computation power. And again, it will not require too much investment at the developer point of view. Let us discuss about a few points about the SDFS. So in Hadoop, the data is located within distributed file system. SDFS is similar to the all local file system. Local file system are designed to store the information. Same way, Hadoop distributed file system is designed to store the information in a distributed environment. The processing model is based on data locality concept, wherein computational logic is sent to cluster node containing data. So it will follow the data locality concept, as well as computation logic is distributed among the cluster node, and these cluster node will have a large amount of data within them. This computation logic is nothing but a compiled version of program written in high-level language such as Java, such as program processing data storage in Hadoop SDFS. So when we can write the whole application which can work on the Hadoop MapReduce system using the Java language. So when we are writing the basic Java program, we are not writing our program to work on a distributed environment. But when we are writing our Hadoop MapReduce program, then we have to be very much careful how the whole logic will be work with the Hadoop MapReduce framework. Okay, so guys, we'll discuss about the Hadoop ecosystem and component in next session, and I think that will be uh, sufficient for today lecture. So if you have any question and answer or any issue, you can, this session will be open for the 10 minutes. And you can put your queries using the chat box, or you can unmute yourself and express your view. And thank you for joining the session.